Today we're going to do 3.3. We've already done a lot with circles in 2.6 and parabolas in 3.1 and 3.2. So 3.3 we're going to switch to an ellipse. We're going to start off similar to how we started off with parabolas. We started doing the center at the origin with a parabola, and then we moved the center to a point h comma k, which was anywhere other than the parabola, or than the center. Sorry. So starting with an ellipse, we're going to start it at the center at the origin. So I'm on page 118 in your book, and it tells an ellipse is a set of all points in a plane such that the sum of the distances of P from two fixed points on a plane is constant. What that means is you have an ellipse, and we're going to put it on the XY axis at your origin. Center's at your origin. We're going to have two different focuses for an ellipse. So your parabola had one, an ellipse has two, sorry. Plural of focus is a foci. So we're going to have a focus here and a focus there. The nice thing about ellipses is there's a lot of symmetry going on in an ellipse. So if you can locate the center, here it's at the origin, your focuses should be exactly the same distance away from the center. The nice thing about that as well is your vertexes are the exact same distance away, both horizontally for your vertexes, and the ends on your minor axis are also going to be very symmetrical. Makes it a whole lot easier. So what this definition is saying is that we have the set of all points P. So they're picking a point out here on the ellipse to be P. And they're saying the distance from that point to each focus. If you add the two distances together, it should always be the same number. It should always be a constant number. You take the distance from this focus to P plus the distance of that focus, it'll equal one number. Then if I were to move P and put P over here, the distance from this focus plus the distance from that focus should still be the exact same number we got the first time. Shouldn't be anything different. Should always be constant. The book is going to call it 2a, is how they're going to refer to that constant. That's not anything that changes. Every time you're going to see it on the second page, page 118, the formula there about halfway down. It's the square root x plus c squared plus y squared plus the square root x minus c squared plus y squared equals 2a. That's the formula about halfway down on the chart, on the sheet. What that is this one is the distance from this point to P. So we're ignoring the second triangle that I drew. That's the first one. Plus you have the second one. This is xy. Your focus, it shows it down lower on that page. They put the focus as C, so this is 0, x, this is C comma 0, and this is negative C comma 0 for your focuses. And you'll learn these letters are actually going to help you out a whole lot. You always want your focus to be the letter C, as in cat. Adding the two distances together should give you the constant of 2a. Again, that's not anything that's going to change. It should always be 2a. We're going to do all sorts of stuff. You won't have to worry about that too terribly much, but it will come back and be important in future sections. Okay. The next thing they give us is the actual formula for the parabola. They do all sorts of math to this equation. They're going to get one isolated radical, square both sides, combine like terms, isolate the other radical, square both sides, combine like terms. We dealt with problems like that earlier on in the semester in our homework, so I'm not going to actually work all that out for you on a video. So we're going to skip to the second page. Page 119 is the formula. They give you a couple of formulas there. One of them is actually in the paragraph. You've got to read to get to it. The main formula is the formula for an ellipse. X squared over a squared plus y squared over b squared equals the number 1. Now we talked about A, B's, and C's, or we talked about C in a focus, right? And I said C is always going to be your focus, so it's really nice that they use the letter C there. But here there is no C. X squared over A squared plus Y squared over B squared equals 1. We're missing the C. So if you read in the paragraph at the top of 119, it gives you a formula for C. It says letting B squared equal A squared minus C squared. Don't try to make this Pythagorean. It has nothing to do with the Pythagorean theorem. So it does not come from that theorem. This is something all on its own. B squared equals A squared minus C squared. You need to have both of these memorized to deal with ellipses. Okay? So you have your parabolas, you have your circles, now you have your ellipses. We'll do hyperboles next. You have a lot of formulas for this section. Make sure they get memorized. The problem with ellipses, and you may notice down at the bottom, they give you a second formula. They give you y squared over a squared plus x squared over b squared equals 1 as well. They are very, very similar. The only difference is the x's and the y's are in different spots. They've switched up on us. The way the book explains this, it says that here x comes first. So your major axis is the x-axis. That means that the parabola is going to be wider than it is taller. The major axis is the longer axis of the two pieces. It's going to be wider according to this formula. Here the y squared comes first. According to the book, that means that the major axis is the y-axis. It's going to be stretched vertically. It's going to be taller than it is wide. The only problem I have with this, and you're going to see this in your homework, is sometimes they're not in the right order. It's not always the variable that comes first is your major axis. So what you're going to look is it's going to depend on the denominators. Whichever denominator is larger, that tells you which axis is the major axis, and we'll get into it in just 1 minute. So down on page 119, they give us a picture, and they tell us that we have an ellipse, and they're stretching it wide. So since this one's stretched wide, it's got more, the points on the x-axis are wider apart, right, than the points on the y-axis. That means the major axis is the x-axis. It's the one that has the most amount of points on it. So from here, they give us our vertexes. They give us negative a comma 0, assuming that was the vertex up here. Fix that one. A comma 0. They give us the ends. We need to have the ends of the minor axis. That's going to be on the parabola at the top and bottom. It's be 0 comma b and 0 comma negative b for your minor axis. They give us the foci, negative C0 and C0. So this is your vertex and your focus. Vertex prime, focus prime, just for the second one. Okay? They have these points labeled as B just for your minor axis. The B is very important that you make sure you know that's B. The other thing they have is they have a vertical line drawn through your focus on both of them with points at the end of those. What this line is that is your lattice rectum. Okay, that's telling you when do you make it wide. Does it start off and get super wide, or does it kind of slowly get wide? By knowing that, and it's always going to be opposite or perpendicular to the focus, you can find the length of that relatively easily. So that point is negative C, because it's got to be the same as your focus, and then B squared over A. This is going to be negative C and negative B squared over A. And again, all this is coming from the picture on page 119. This one will be positive C because it's lining up with your focus, and B squared over A. There's a lot of symmetry going on here. This point is positive C, negative B squared over A. So if you look top to bottom, the only difference is the signs, right? 0b, 0, negative b. Negative c, b squared over a. Negative c, negative b squared over a. C, b squared over a. C, negative b squared over a. If you look left to right, the only difference should be your signs. We have negative a0, a0. Negative c0, positive c0. Negative c, negative b over a. Positive c, negative b over a. It's only on the x value sign. Vertically, it's the y value sign. There's a lot of symmetry going on here. You're going to rely on that symmetry heavily. So the good thing about this, with all the letters, your vertex are always A. So A is going to be your vertex. And that comes in real handy because you can get that straight from the formula. You can say a squared, well, square root of whatever number is underneath, or the larger number is always going to be your vertex. B is going to be the ends of the minor axis. It's kind of like your minor vertexes. Where does it stop, top and bottom? Okay? And C is going to be your focus. So A and B can be found very easily from your original formula, as long as it's in standard form. This is standard form for those two. C, you've got to do a little bit more work to get. You use your b squared equals a squared minus c squared to get your c. Okay? Terrible, horrible? Hopefully not. The next page, it has the axis stretched vertically, which would be your y squared. Again, don't let these standard equations mess with you. It's always the major axis is the one that has the larger denominator. Alright, so let's look at example 1 on page 121. Find the equation of ellipse with a focus, or foci, at 0 plus or minus 4, and a vertex at 0, 6. So we have foci at 0 plus or minus 4. Zero, 6. So the plus or minus 4 is just our shorthand of writing two separate points. This is the point 0, 4 and 0, negative 4. They're lazy, so they wrote it as one point with the plus or minus. I like to start with a picture. Now, don't get too gung-ho and put these all on the x-axis. It's really easy to do. Since the x value is always 0 for both of these, that tells you they're both on the y-axis. So 0, 4 is here. 0, negative 4 down there. And your vertex is 0, 6. Okay. Now we know there's a lot of symmetry. We can already tell where the other vertex is. Right? It's going to be at 0, negative 6. But that doesn't really matter because we're not looking for the graph, we're looking for the equation, right? So we have to identify what A and what B is and what C is. A and B is the most important. So they give us the vertex. Vertex is always A. And they want to know how far from the center of the ellipse is your vertex. So from the center, it goes up and down how many? It's up 6 and it goes down 6, right? So A is plus or minus 6. Because from 0, your vertexes go up 6 or they go down 6 to get both of them. Okay? Then they want to know your B, which is your minor axis. They didn't give us B. B would be on the opposite axis. Since everything we have is on the y-axis, our B should be on the x-axis to make the actual ellipse. Since we're missing that, let's go on to our focus. Our C is our foci, which, again, that's looking from the center of the ellipse, how high up, how low, what's the change to get to the focus. So it goes up 4 and it goes down 4, so that's plus or minus 4. And then we still need the B in order to get our equation. Remember our equation Looking here, since everything's on the y-axis, including our vertex is on the y, that means our equation should start with the y. Our major axis is y. So y squared over a squared plus x squared over b squared equals 1. We have half of it. We have the a. We have y squared, x squared, 1. We're just missing b. So to find the b, we're going to use that second equation they gave us. B squared equals a squared minus c squared. It's the second equation. If you want to go back to it, that's on the very top of 119. B squared equals a squared minus c squared. For this, we're going to plug in what we know. We know a, we know c. So a is plus or minus 6. If we square that, we get 36. C is plus or minus 4. If we square that, 16. Do the math, b squared equals 20. If you want to solve all the way down for b, you can. You get b equals plus or minus the square root of 20. Just a little bit more complicated to deal with. However, our equation wants an a squared and a b squared. It doesn't want just b, right? It wants b squared. We don't care about b. It wants a squared, which is plus or minus 6. Squared is 36. And it wants b squared, which is 20. And you're done. If you go too far, that's fine. Because once you plug this into the equation, you're going to take it, you're going to square it, you're going to get 20. So don't worry if you go too far, that's perfectly fine. I did the first bazillion times. I went too far, I'd plug it in the equation, I'd square it out, I'm like, oh, I didn't have to do that stuff, that's right. Don't worry about it, it's not going to hurt you. All they want here is the equation. If they wanted you to graph it, you'd have to find root 20 on both sides, find the length of your lattice rectums, and finish it off. But we'll do that in the next one. So example 2 is sketch the ellipse 9x squared plus 25y squared equals 225. Still on page 121, example 2. So let me clear the board real quick. All right. So sketch the ellipse. So here they want us to graph it. Okay. So what we're going to do is we need to put it into standard form. It's not in standard form yet. Standard form is always equal to 1 for your circles, your ellipses, and your hyperbolaes. So you want to make sure here it's equal to 1. Right now it's equal to 225. If we subtract 225, it'll be equal to 0. So we don't want to do that. We want to divide. Anything divided by itself equals 1. So if we divide everything by 225, that should become 1. That'll divide out. And that should divide out. Okay? So that's going to give us x squared over 25 plus y squared over 9 equals 1. If you're not sure how to do this, well, all I'm doing is reducing the equation. You can do 9 divided by 225, just make sure it gets put back into a fraction, not a decimal. You do not want decimals. You can do 225 divided by 9, that should give you positive 25. Then you'll look and say, okay, the bigger number was on bottom, that's got to be left on bottom. So if you want to do it that way, it works as well. So here, just from the equation, we're going to look at our denominators. The x squared's denominator is 25. The y squared's denominator is 9. Meaning that since the larger one is underneath the x squared, the major axis is being stretched horizontally. It's the x-axis. So our vertexes, our focus, should both be on the x-axis. B should be on the y-axis since it is smaller. So you can tell just from the equation, a squared is 25, and that's your vertex, which means that a is plus or minus 5, because you're going to square root both sides, Anytime you make a square root symbol appear, b squared equals 9. So b equals plus or minus 3. Again, take the square root of both sides. Okay. Unfortunately, an ellipse is not as simple as just finding the 4 points. Because then you have all sorts of shapes you could make. We know, I'll put my graph over here, that your major axis is the x-axis. So we're going to go from our center 5 each way to get our vertexes, and 3 up and 3 down. Well, I mean, this could go and be kind of chunky and square-like. It could also go and be more slim. I mean, there's a variety of ways that this could go. We've got to figure out, when does it get to its max? When does it start to actually round out? Does it start at the beginning and actually make a nice curve from there? Or is it still skinny in the beginning and slowly get larger? So the way we do that is with our focus and our lattice rectum. So starting off, let's get the focus. We have the equation b squared equals a squared minus c squared. C is always your focus. So vertex is A, minor axis is B, C is your focus. We know b squared is 9, a squared is 25. We do not know c squared. So if we solve for c squared, we're going to subtract 25. Negative c squared equals 16, negative. Divide by negative 1. C squared is 16, which means c is plus or minus 4. Okay. So if c is plus or minus 4, that's your focus, meaning you're going to have those points right there on your major axis. Last thing we need to do is the lattice rectum, which is given by a formula in the next paragraph, 2b squared over a. Which we already know that information. We have your b squared is 9, a is plus or minus 5, right? Focus on the positives or actually, you could do plus or minus. We do 2 times 9 divided by plus or minus 5. That gives us 18 over 5 plus or minus. That's going to tell us how far away from the foci it is. So you're going to divide it in 2 so you can get only half the length, because this is the entire length. So divided by 2, you get plus or minus 9 over 5 for how high up and how low it goes. 9/5 is just below 2. So that's going to be about right there on this side, and you've got a second focus, so about right there on that side. And you have your ellipse. Okay. The next thing they talk about is the focus directrix property. We've talked about the parabolas having a directrix, but we haven't really mentioned it on an ellipse. So on an ellipse, there are 2 directrixes, and you can see them on page 122. However, we're going to focus a little bit more on the actual ellipse and the equations. So the next thing we're going to do is an ellipse with a center at h, k. So just like with parabolas in 3.2, we're going to move the center and have it on an ellipse as well. Your formulas are going to be very similar to your parabolas, how you had the minus h and minus k. So your formula is x minus h squared, still over your a squared, plus y minus k squared, still over your b squared, always equal to 1 with your circles, your ellipses, and hyperboles when we get there. Okay, so this is your standard form. It's going to be done very similar to how we did parabolas in 3.2. So the first example is find the equation of ellipse with a foci at 4, -2. and 10, negative 2. And then it tells us also the vertex is at 12, negative 2. Okay. So our first thing we've got to do is find the center. Since these are at different points and they can't just do a plus or minus, that tells us the center's not at the origin. So if you put it in a graph, everything's going horizontally. We have our x-axis and our y-axis. 4, negative 2. We would have 10, negative 2. And for our vertex, 12, negative 2. Since everything's lined up horizontally, that tells you your major axis is the x-axis because it's horizontal. So your equation should start with x, not with y. Make sure you are using the correct standard form of the equation. First thing we have to do is find the center. We know with ellipses there's a ton of symmetry involved. So you're going to take your two focuses and say, what's the center between 4 and 10? So that's going to be your 7. It's the easiest way to find the center is just to look at the 2 and count your way to the center. When you get to the middle, it's 7, negative 2. So we've figured out that. Now the problem here is we don't actually know A. A so far has been your vertex. Here it's 12, but 12 is not our A because it's not from the origin to the vertex, it's from the center to the vertex. So when we look at our vertex, we need to be able to relate it in terms of our center. So we know our major axis is our x-axis, so that's going to be one the vertex will change. We need to do 7 plus or minus a number, negative 2. How can you get to your vertex in relation to here? 7 plus 5 would be your vertex, would be 12. If we do 7 minus 5, that'd be negative 2. 7 minus 5, sorry, that'd be positive 2. That gets you your other vertex. So your A is whatever's being plus or minus. For your equation, we need A squared, which is 25. Your B comes from the minor axis, which they don't tell us. But we can figure it out if we can get C. Again, C is not 4, it's not 10. You need to relate the focus in terms of, should we still be plural? In terms of your center. So 7 plus or minus something, comma negative 2. So 7 plus or minus something, you get 4 and 10. 7 plus 3, 7 minus 3. Give you 10, give you 4. So your C is plus or minus 3. You square that to use your formula, gives you 9. So to get your B for your minor axis, B squared equals C squared minus A squared. Again, make sure that's memorized. This is for ellipses only. B squared is, we don't know. C squared is 9. A squared is 25. A squared minus C squared. I'm sorry, I had that formula wrong. Otherwise, you get what we saw. You have a negative, and you can't take the square root of a negative. 25 minus 9 gives you a positive 16. You want to take square roots of positives, otherwise things turn out imaginary. Take the square root. B equals plus or minus 4. However, we didn't really need to take the square root, but if you're just in the habit, I did that just out of habit. So your formula, they wanted it in standard form. We need x minus h, that's going to be your center. X minus h over a squared plus y minus k, y minus opposite of your y value, so that'd be y plus 2, over b squared, you just found out to be 16, equals 1. And that is your equation. The graph just helps you kind of keep track of what's actually going on and what's not. All right, and your last example, example 5 on page 126, reduce to the standard form of the equation. So we have 4y squared plus 9x squared minus 24y minus 72x. Plus 144 equals 0. We need to get this into that standard form of the x minus h squared over a squared plus y minus k squared over b squared equals to 1. And in order to do that, we've got to complete the square. So we've already been completing the square a little bit in chapter 3 already. Start off by getting the number term to the other side and organizing the x's and y's to be grouped together. So the 4y squared, I need to group it with the other y. So keep the sign, just move it around. Plus your 9x squared with your other x, keep its sign. And we're going to move the 144 to the other side of the equation. Okay. Now to complete the square, you need to make sure your squared term is all alone. If you can divide everything and get rid of the pieces in front of both squares, do it. Here, 4 and 9 are not divisible by each other. So we're going to have to factor them out. So we're going to factor out whatever numbers with y squared just from those two pieces. Take a 4 away from y squared, divide it away, you're left with only y squared. Negative 24y divided by 4 leaves you with negative 6y. Plus, you're going to factor a 9 out as well. Take your 9, x squared is left, minus negative 72 divided by 9, 8x. Okay? What we have to do now is the actual completing the square. What we want to end up is something that we can factor into a factor squared. We want a perfect square trinomial. So your outside coefficients are just going to fall down. Actually, save a little bit of room as you do that. And then it's going to start off exactly the same, y squared minus 6y. You're going to take the middle coefficient, including the sign, divide it by 2, and square it. Negative 6 divided by 2 is negative 3. Squared equals 9. We're going to add 9 inside here, but what we do to one side, we must do to the other. However, we can't just add 9 over here, because 9 is being multiplied by 4. So over here, when we get to our other side of our equation, we've got to add the 9 already multiplied by the 4. 36. Do the same thing for your x's. This 9, the outside coefficient, falls down. X squared minus 8x. Take your coefficient of the regular term, divide it by 2, and square it. Gives us negative 4 squared, which gives us positive 16. Add 16, but you can't add 16 over here because it's still being multiplied by 9. So 9 times 16, you're going to add the 144 to get that. What happens over here, since we've done this, the whole reason of doing this is we want to be able to factor this trinomial into something squared. It's going to make it nice and simple and clean so that we can get our standard form that we want. The joy of completing the square is it'll always factor to the letter you're dealing with, just one of them, and as long as you keep the sign, whatever before you squared it, minus 3. plus your outside factor falls down, you're gonna be left with the letter that you're dealing with. And as long as you keep your sign, whatever's inside, squared. Negative 144 plus 144 goes away, you're left with 36. You know your ellipses are always equal to 0, so divide 36, divide 36, divide 36. Should cancel out, leaving you y minus 3 squared over 9 plus x minus 4 squared over 4 equals 1. This tells us our vertex, or our center, is at 4, 3, because keep the x with the x. And then our vertex is moved plus or minus 3 units, and our minor axis is moved plus or minus 2 units, because it's always square roots. So that is your equation in standard form. This is 3.3. If y'all have any questions, email me. My email is JELAUGHLIN@dccd.edu. I will have my computer. I'm on it all the time. Don't hesitate to email me. How y'all guys?
Pretty good.